Hi, in this video tutorial we will be taking a look at inequalities, and we're looking specifically at the higher tier for the GCSE 9 to 1 for the AQA, OCR, Pearson Edexcel and WJEC specification. Okay, so it's aimed at predominantly for the GCSE 9 to 1 higher tier, although some questions will be appropriate for foundation and I will point them out as we go along, and it also may be appropriate for those of you doing AS level pure maths or even A2 level pure maths or even general maths, okay, in general, yeah, like beyond GCSE level. Okay, this is question number 1. Solve this inequality. 5x minus 2 is greater than 3x plus 11. So step 1 is to add 2 to both sides. Okay, so whatever I do to one side of my inequality, I must do the same to the other. So I get 5x is greater than 3x plus 13. Okay, because the minus 2 plus 2 goes to 0. 3x plus 13. I'm then going to subtract 3x on both sides of my inequality because I want to try and get all my x's on one side and all my numbers on the other side of my inequality. So then I get 2x is greater than 13. Dividing both sides by 2, I get that x is greater than 13 halves, okay, or 6.5, or x is greater than 6.5, okay, either one is fine, okay, so anything equivalent to 13 halves, okay, so x is strictly greater than 13 halves. This is question number 2. Solve this quadratic inequality. Well, what I'm going to do is I'm going to bring the 3x over to this side, and I'm going to bring the 4 over. So then my quadratic, okay, let's just delete this here actually and write the answer somewhere else for question 1. But question 1, guys, the answer should be x is greater than 13 halves or anything equivalent to 13 halves. Okay, so what I'm going to have here is I'm going to have x squared. Oops. Let's just do this again. I'm going to have x squared subtract 3x subtract 4, and that has to be greater than 0. Okay, so I'm treating this the same way like I do with a quadratic. So it's always bringing it, so I have the greater than 0, greater than or equal to 0, less than 0, or less than or equal to 0. I'm now going to factorize this quadratic, okay, into x plus 1 times x minus 4. Again, okay, so factorizing it into double brackets, okay, it's two numbers that add to give me -3 and multiply to give me +4. So it's +1 and -4, or -4 plus 1. Okay, so sketching this actually, so let's just do this up here actually, so we've got slightly, not got much space here actually either. Okay, so it crosses at 1 and it crosses at 4, okay, so it's a rough sketch. So it looks something like that, okay? And we want it so the graph is bigger than 0. So it's when it's above the x-axis. It's above the x-axis here, and it's above the x-axis in this region. So my answers are that x is strictly less than -1, or x is bigger than 4, okay? And those numbers have come from, because if I solve this quadratic, it crosses the x-axis at -1, 0 and 4, 0, okay? If I set this quadratic equal to 0, I get either x plus 1 is 0 or x minus 4 is 0. Therefore, it crosses the x-axis at -1, 0 or 4, 0. We want it where it's above the x-axis. So this, remember, this is my x-axis. Okay, so above it is going to be x is less than -1 or bigger than +4. Okay, so that is solving quadratic inequalities. Okay, This is question number 3. Solve this inequality. Well, if I subtract 4 on both sides, I'm going to get 6x is greater than x plus 13. Okay. If I now subtract x on both sides of my inequality, so I get that 5x is strictly greater than 13. Okay, it should be a 5 and not a 3 there. Sorry. Dividing both sides by 5, I get that x is greater than 13/5. Okay. And that's my answer for that question, guys. Okay, so I appreciate it. It's not much like space here, and sorry if it is a bit squished at all, but feel free to obviously pause the video and look at what I've done here step by step. Okay, and if I have jumped any steps, then please do let me know in the comments section. Okay, this is question number 4. N is an integer with this inequality. -5 is less than 2n, less than or equal to 6. Write down all the values for n. Well, if I divide everything by 2, because 2n means 2 times n, I'm going to get -5 halves is less than n and less than or equal to 3. Okay, now from there I can say, okay, well, integer means whole number, so n has to be greater than -2.5 and less than 3. So n could equal -2, -1, 0, 1, 2, and 3. Okay, so they are all the possible values that n could be. N can't be equal to 3 because it has to be greater than -5.5. Remember that -5.5 is -2.5 as an improper fraction, which is -2.5. Okay, so obviously -2.5 is bigger than -3, so n can't be equal to -3. Okay, but that's my inequalities. This is question number 5. Solve this inequality. If I -1 on both sides, I get that 5x is greater than x plus 12. If I now subtract x on both sides of my linear inequality, so to balance it, I get that 4x is greater than 12. Dividing both sides by 4, because 4x means 4 times x, I get that x is greater than 12 divided by 4, which is 3. Okay, this is part II. Write down the largest integer that satisfies this inequality. 5x minus 1 is less than 10. Well, if I add 1 to both sides, I get 5x is less than 11. Dividing both sides by 5, I get that x is strictly less than 11/5, which is the same as 2.2, okay, or 2. So the largest possible integer that it can be has to be 2, okay? Because that's the largest possible value that it can take that will satisfy that inequality. It can't be 3 because 3 is bigger than 2.2. It has to be strictly less than 2.2. And since 2.2 is not a whole number, the nearest whole number closest to 2.2 going down, in our case, is going to be 2. Okay, so that's the largest possible whole number. Remember, integer means whole number, guys. This is question number 4. Okay, so let's just delete this here so I've got a bit more space to read. Okay. Right, here are two function machines, A and B. Input, okay, square, add 6, output. Input, subtract 3, and square, output. Both machines have the same input, so let's call that x and x. Work out the range of input values for which the output of A is less than the output of B. Okay, so the output of A, so if I square it, I get x squared, and then if I add 6, my output is just x squared plus 6, or 6 plus x squared. The next one, if I subtract 3 and then I square it, I get x minus 3 all squared. Now the question is saying to find the range of input values for which the output of A is less than B. So it's saying for what value of x is x squared plus 6 strictly less than x minus 3 all squared. Okay, so it's asking us to solve this inequality. So expanding this double bracket on the outside, I'm going to do it in one go actually, but hopefully it makes sense. X squared minus 3x minus 3x minus 6x plus 9. Okay, and then I've got an x squared plus 6. I can subtract x squared on both sides. Okay, so that's going to cancel. So I get 6 is less than minus 6x plus 9. I'm going to add 6x to this side, and then I'm going to bring this 6 over. So I get 6x is less than 9 take away 6, which is 3. Okay, so 6x is less than 3. Dividing both sides by 6, we get that x is less than a half, okay, or 3 over 6, which is equal to a half. So the range of values for which the output of A is less than the output of B is when x is less than a half, okay? So that will give us that the output of A is less than B. This is question number 7. Solve this linear inequality. 5x plus 9 is greater than 13. Well, if I subtract 9 on both sides of my inequality to balance it, I get 5x is greater than 4. Dividing both sides by 5, I get that x is greater than 4/5. Okay, or x is greater than 0.8, either is fine. This is question number 8. Circle the inequality shown by the diagram. So it's minus 7 to 6. Okay, so it's got a shaded circle, so it's minus 7 is less than or equal to x, so it's any number bigger than minus 7 or equal to minus 7 and less than 6. Well, that's going to be this inequality one specifically. Okay, so it's bigger than or equal to minus 7 and less than 6 because it's got a hollow circle. Okay, this is question number 9. Here is a cuboid. All measurements are in centimeters. Okay, x is an integer. The total volume of this cuboid is less than 900 centimeters cubed. So that x is less than or equal to 5. Okay, so the volume of a cuboid is length times width times height. So it's going to be x times 3x times 2x. So I get 6x cubed. Okay, is less than 900. Okay, so the 6x, just to be clear guys, has come from x times 3x times 2x. That's giving me the 6x cubed there. Okay, I'm now going to divide both sides by 6. So I get x cubed is less than 900 divided by 6, which I believe is 150, because 15 times 6, I believe, is 90. Okay, because 15 times 3 is 45, so double of 45 is going to be 90, yep. Okay, so yeah, so 900 divided by 6 is equal to 150. 6 into 9 is 1, remainder 3, sorry. 6 into 30 is 5, remainder 0, and we have 0. The last step is to do x is less than the cube root of 150. Now the cube root of 150 gives us an answer of 5 point something, and the reason I know that, okay, is because the cube root of 125 is 5. So that means that my answer has to be less than 5 point something. So the nearest whole number, because x has to be an integer, has to be that x is strictly less than or equal to 5. Okay, because when x equals 5, then it does actually satisfy this inequality here. Okay, 5 cubed is 125. 125 times 6 is less than 900. Okay, so you can check that for yourself, guys. Okay, so the cube root of that, yeah, gives me like a decimal answer, 5 point something, like 5.31 something, I think. Okay, but the idea is that it's bigger than 5, therefore the nearest whole number that is closest to that has to be less than or equal to 5, okay, for us to satisfy that region, okay, and that inequality. This is question number 10. On the grid, shade the region that satisfies all these inequalities. Label the region R. Okay, so we've got the line x plus y is less than 4. So let's just rearrange this and write it in the form. So if it's minus x on both sides, I get that y is less than minus x plus 4 or 4 minus x, okay? So that's going to look something like this, okay, roughly. When x is minus 1, y has to be equal, okay, so it's going to follow this sort of pattern. Now, a little disclaimer, guys, obviously I haven't got a ruler here, but you would obviously make sure that you use a ruler when you draw these, okay, but that's like the point in the graph, okay. It is a less than, so it's like a strict inequality, okay, so it's a dashed line, okay, because it's a less than. Y is bigger than x minus 1. Well, x minus 1 is going to look something like this, okay. Okay. So it's got a gradient of 1 and it goes through minus 1, okay. And it has to be bigger than that, so it has to be in this region here for that line, and for this one it has to be less than, so it's going to be in this region, okay? And last one is y is less than 3x. Well, it goes through the origin and it's got a gradient of 3. So along 1 and then up 3. Okay, along 1 and then up 3. Okay, along 1 and then up 3. Okay, so it looks something along 1 and then down 3, along 1, then down 3. Obviously it is off the page here, but you get the idea. So if I just do, again, it's a dashed line because it is a less than, okay. Okay, so it's a dashed line, and it's saying that y is less than ever, so it's going to be in this direction, okay. So if y is less than 3x, let's just pick a point here. X is 3 and y is 5. If x is 3 and y is 5, actually, okay, so it can't be that, actually, so it has to be on this side. Okay, so this is the bit that we want, actually, so it's going to be in this region here, essentially. Okay, is what we want. Okay, in this part, so if I label it, we're going to be looking at this R here, so it's this little triangle here, okay, that we are looking for, because it's in this direction, it's up from here and it's less than that, so this is going to be the region that we want, okay, I believe. Okay, so I believe it's also going to be that as well, actually, so it's going to be all of this is what we want. So I'm going to label that as just capital R, okay, as well as that triangle there, so that's also going to be included as well, okay, but it can't pass that line there, actually, so it's got to be everything on this side of my line. Okay, this is question number 11. Solve the inequality x squared is bigger than 3x plus 6. So expanding the bracket on the right hand side, I'm going to have x squared is greater than 3x plus 6. 3 times x is 3x, and then 3 times 6 is 18. Bringing the 3x and the 18 over, I get x squared minus 3x minus 18 is strictly greater than 0. Okay, again, factorizing this quadratic, okay, and then looking at it graphically, I get x plus 3 and x minus 6. Okay, so it's two numbers that add to give me negative 3 and multiply to give me negative 18. So it's going to be 3 and 6. Okay, so sorry, negative 6 and then positive 3. Okay. Right, again, so looking at this graphically, so it crosses the x-axis at minus 3 and 6. Let's going to say here, So it looks something like that, roughly, for like a rough sketch. That's going to be minus 3. That's going to be 6, So that's where it crosses on the x-axis. We want it when it's above the line. So it's going to be this region here. Okay, so above the x-axis, sorry. So remember that's my x-axis, so it's above that line. So it has to be x is strictly less than negative 3, or x is bigger than 6. Okay. So that's my answer for that question. Okay, this is question number 12a. Solve the inequality 3x divided by 2 is less than or equal to 9. Whenever times both sides by 2, I get that 3x is less than or equal to 18. 9 times 2 is 18. Dividing both sides by 3, I get that x is less than or equal to 6. Okay. This is part B. Solve the inequality 4 bracket x plus 12 brackets is greater than 12. Well, expanding that bracket, I get 4x plus 8 is greater than 12. Subtracting 8 on both sides, I get 4x is greater than 4. Dividing both sides by 4, I get that x is greater than 1. Okay, so x is greater than 1. Part C says represent the solution set that satisfies both the answers in part A and part B on the number line. So it's x is less than equal to 6, okay. So it's going to be a circle because it's got the equal sign, and then bigger than 1. So it's going to be a hollow circle like that, okay. So x is in between 1, oops. Not a 6, sorry. X is greater than 1, but less than or equal to 6 is the bit that satisfies both part A and part B. Okay, so I hope that makes sense. This is question number 13. Okay, so plotting the region R. So the region R satisfies the 3 inequalities. X is greater than minus 3. X plus Y is less than or equal to 2, I believe. Okay, and then y is greater than or equal to x minus 1 over 2. Okay, if it isn't a equal sign, guys, then I do obviously apologize in advance to you, but it looks like an equal sign here to me, and looks like an equal sign here. So x is bigger than negative 3. Okay, so that's going to be a vertical line. Okay, so this is the line. Oops, x equals negative 3. Okay, so it's so it's going to be everything on this region with that big arrow. Okay, the next one is x plus y is less than or equal to 2. Well, that's going to look something like this. Okay, so plotting the points there. And again, it's going to be like a straight line. Make sure that we use like a ruler for these questions, guys. Okay, and it's less than, so we are wanting this region here. So it's going to be somewhere down here. It has to be. Oh, sorry, it's somewhere down here. Sorry, ever. So it's, let's just rule that out here. But that's obviously the whole region. So it's going to be somewhere down here that obviously satisfies both. And the last one is y is greater than or equal to half x minus 1. So x over 2 minus 1. So it is going to go through minus 1 on the y-axis. When x is 1, we get a half take away 1, which is going to be minus 0.5. So it's going to be somewhere here. Okay, so this one's going to be a bit more trickier. When x is 2, 2 divided by 2 is 1. It's going to be there. Okay, when x is 3, 3/2 minus, it's going to be somewhere here. Okay, so it's going to look something like that. Okay, so yeah, it is a bit like steeper. Okay, so it's something like that, and y is greater than or equal to, so it has to be up here somewhere. Okay, so the region that it could be is all of this here. Okay, so show R on the grid. Well, everything in that I'm seeing over here, so everything in this triangle is the region R. So it's this whole bit here, guys, just to be clear. So it's everything here, here, and here. Okay, within that region there. Okay, so that's going to be my capital R. Okay, so that's my answer for that question, guys. Okay, so that takes us to the end of the first worksheet. Okay, so here are the questions on where it appears on the AQA, Pearson Edexcel, and OCR. Okay, so feel free to obviously check them out, yeah, for the exam papers. Okay, and then here are the links. Okay, it has not got the years on there, but it comes from the previous past papers. Okay, whether it's a specimen or the most recent papers, or the 2017 or 2018 papers. Okay, but it's all on there. Okay. Right, guys, so we are now looking at exam QA, so GCSE Edexcel Mathematics 9 to 1, okay, and we're also looking at inequalities again, actually, so it is from the examqa.com website, so feel free to check that out for maths. This is question number 1. By considering the number line, fill in the box with less than or greater than. Part 8, so 2 and 7, so 7 is bigger than 2, so 2 is less than 7, or 7 is bigger than 2. Part B, 7 take away 2 and 12 take away 2. Well, that's going to be bigger, okay, because 12 take away 2 is 10, 7 take away 2 is 5. Next one, that's going to be bigger again, okay. Next one, 9 is bigger than negative 7, okay. For that one, okay, the next question, guys, okay, which is bigger, 5 plus 2 or minus 12 plus 5, or 5 plus 2 is bigger than minus 12 plus 5, because 5 plus 2 is 7, and minus 12 plus 5 is minus 7, so 7 is bigger than minus 7. The next one is 1 minus 4 is minus 3, and then I'm going to have minus 10 here. Remember that the bigger the negative sign, the smaller my number. So what I'm saying is minus 3 is bigger than minus 10. Okay, this is question number 2. N is an integer such that it satisfies this inequality. Write down all the possible values of n. So n is bigger than or equal to minus 2 and less than 2. So n could equal minus 2, minus 1, 0, and 1. Okay, n can't equal 2 because it's strictly less than 2, but it's greater than or equal to minus 2. Okay, so this is like another way of writing what it's saying there. N is greater than minus 2 or equal to minus 2, and then n is less than 2. Okay, when it's got the little line underneath, and it means greater than or equal to, or less than or equal to, so it includes that number as well. This is question number 3. N is an integer such that it satisfies minus 1 is less than or equal to n less than 5. Write down all the possible values. Well, n could equal minus 1, 0, 1, 2, 3, and 4. But remember, it can't equal 5 because it's strictly less than 5. Okay, this is question number 4a. On the number line, show the inequality x less than 3. There's going to be a hollow circle, and it's less than 3, so it's going in this direction, because it has to be smaller than 3. Remember that going to the left makes it smaller on my number line, going to the right makes my number bigger than that. Okay, part B, solve this inequality. Well, if I subtract 5 on both sides, I'm going to get that 3y is less than or equal to 6. Dividing both sides by 3, I get that y is less than or equal to 2. Okay, this is question number 5. Write down the inequality shown on this number line. Well, it's a shaded in circle at minus 2, so its x is greater than or equal to negative 2. Okay, this is question number 6, guys. Minus 2 is less than n, less than or equal to 3. Write down all the possible values of n. So this time n is greater than minus 2, but less than or equal to 3. So it's minus 1, 0, 1, 2, and 3. And that'll be my answer for that question. Okay. Part B, solve this inequality. So 4x minus 4 is greater than 16. Adding 4 to both sides, I get 4x is greater than 20. Dividing both sides by 4, I get that x is greater than 5. Okay, this is question number 7. On the number line, show this inequality. So it's a hollow circle for minus 3. It's bigger than minus 3, but less than 5. Okay, so it's going to be a hollow circle there. Okay, so let's just draw this line again. Straight line. Okay, from there. Okay, and it's a hollow circle because it's not got the equal sign. So it's bigger than minus 3 and less than 5. So the values that x could be are minus 2, minus 1, 0, 1, 2, 3, 4. And all the other decimals in between minus 3 and 5 here, if we're looking at decimals as well. Okay, part B. Write down the inequality shown in this number line. Well, it's less than 5. So x is less than 5 because it's a hollow circle. Okay, this is question number 8. On the number line, show the inequality n is greater than 2. Well, it's going to be a hollow circle at 2 and it's going to the right because it's bigger than 2. Okay, next part. 2 is less than or equal to y, less than 9. Write down all the possible values of y. So y is equal to 2, 3, 4, 5, 6, 7, and 8, but it can't equal 9. Okay, 5, 6, 7, and 8. Okay, part C, solve this inequality. Well, if I subtract 5 on both sides, I get 3x is less than or equal to x plus 28. Because 33 take away 5 is 28. If I then subtract x on both sides, I get 2x is less than or equal to 28. Dividing both sides by 2, I get that x is less than or equal to 14. This is question number 9. Solve this inequality. Okay, show your answer on a number line. Well, if I minus x on both sides of my inequality, I get 4x is less than or equal to 12. Dividing both sides by 4, I get that x is less than or equal to 3. There's going to be a shaded in circle here, so shaded in circle, and then it's going, let's do that again. Just a circle, and I'm going to shade it in, and it's going to the left because it's less than or equal to 3. Okay, this is question number 10. Write down the inequality shown on this number line. So it's a shaded in circle there, so it's minus 2 is less than or equal to x, let's say, and it's strictly less than 6 because it's a hollow circle. This is question number 11a. On the number line, show the inequality y plus 2 is less than or equal to 4. Well, if I minus 2 on both sides, I get that y is less than or equal to 2. Okay, so it's going to be a shaded in circle, okay, because it's got the equal sign, and it's less than 2. Okay, part B, so we got 7 is less than 3x and less than 15, where y is an integer. Okay, write down all the possible values. Well, if I divide everything by 3, I get 7/3 is less than x and less than 5. 7/3 is same as saying 2 1/3, so it's 2.3 reoccurring, okay? Less than x and less than 5. So x can only be equal to 3 and 4. Okay, they are the only possible values for that inequality to be true. Okay, part C, solve this inequality. Well, if I add 5x to both sides, I get 3 plus 5x is greater than 18. Subtract 3 on both sides, I get 5x is greater than 15. Dividing both sides by 5, I get that x is greater than 3. This is question number 12. Write down the inequality shown on this number line. So it's 2 shaded in circles. So it's going to be 2 is less than or equal to x, and that's less than or equal to 7. Okay, so it's bigger than or equal to 2, but less than or equal to 7. So if you're interested, so it can take these values. Okay, so it can equal 2, and it can also equal 7 because it's shaded in. Okay, if it wasn't shaded in, then I can't include the two end numbers. Okay, but they are all my values for that inequality. This is question number 13. Okay, so on this number line, show the inequality minus 2 is less than n less than 4. Hollow circle there, and it's going to go right to 4. It's going to be there. Okay, because it's got an equal sign. Okay, part B is going from minus 3 less than or equal to n less than 3. Okay, that's that one there. Next one, solve this inequality. Well, if I expand the bracket, I get 9n minus 12 is strictly greater than 15. If I add 12 to both sides, I get 9n is greater than 27. Dividing both sides by 9, I get that n is greater than 3. Okay, than 3. Question number 15. N is an integer that satisfies this inequality. Write down all the possible values of n. Well, dividing everything by 2 throughout my inequality. Okay. Okay, so it's both improper fractions. So remember that I'm going from minus 2.5 to 6.5. Okay, so when it's in decimal, it's a bit easy to see. So n could equal -2 right the way to 6. Okay, -1, 0, 1, 2, 3, 4, 5, and 6. Okay, sorry if it's gone over the line. Question number 16. Solve this inequality. Well, expanding my bracket, I get 7n plus 7 is less than 49. Subtracting 7 on both sides, I get that 7n is less than 42. Dividing both sides by 7, because 7n means 7 times n, so the opposite of dividing. Okay, n is less than 6. Okay, this is question number 17. Okay, solve this inequality. Expanding my bracket, I get 2x plus 6 is greater than 15. Subtracting 6 on both sides, I get that 2x is greater than 9. Dividing everything by 2, I get that x is greater than 9/2, or 4.5, okay, or 4.5, okay, either is fine. Okay, this is question number 18. On the number line, show the inequality of this. Well, if I add 4 to both sides, okay, of my inequalities, to balance it, okay, the double inequality, -1 plus 4 is 3, so 3 is less than or equal to y and less than 5, so it's going to be a circle there. Okay, sorry, it should be a 3 there, not in between. And then it's just going to 5. There's a hollow circle there. Okay. Okay, next part. So if I add 4 to both sides, okay, so it's asking us for the possible values of y. I'm going to get that y is less than 9 and less than or equal to 7. So the possible values of y are 7 and 8, okay, for that question. Part C, solving this inequality. Well, if I'm minus 2x on both sides, I'm going to have 3x minus 5 is less than or equal to minus 19. If I add 5 to both sides and then divide by 3, 3x is less than or equal to negative 14. Dividing that by 3, I get that x is minus 14, or x is less than or equal to minus 14 thirds. Okay. So that's my answer for that question, guys. Okay, this is question number 19. Anna scored 66 marks in her first class test and 72 in her second class test. What is the minimum that she must score so her total marks is 200 or more? Okay, so 66 and 72. 6 add 2 is 8, and 6 add 7 is 13. Okay, so 200 minus 138, I get the answer to be 62. So it says for a total of 200 or more, so she has to gain 62 marks or more. Okay, so her third class marks, so I'll just call it T for test 3, has to be greater than or equal to 62. Okay, so it has to be 62 or more. Okay, but the minimum, for this question is going to be 62 marks, because it's asking for the minimum. Okay, this is question number 10. X is a prime number. Given that 8 minus x is greater than 3, find the largest possible value of x. Okay, so if I add x to both sides, okay, because I've got minus x there, I'm going to have that 8 is greater than 3 plus x. If I subtract 3 on both sides, okay, 8 take away 3 is 5. So 5 is greater than x, or x is less than 5. Okay. Now the largest possible prime number from that, so a prime number has 2 factors, so it's going to be 2, 3. Okay, so it can't be Fabergé because it's got to be less than 5. So the smallest one would be that x has to equal 3. Okay, so prime number, remember, has 2 factors. Okay, so 2 factors, 1 in itself. Okay, and they're my first few prime numbers. 1, okay, and itself. 1 is not a prime number actually, so there's a lot of misconception. And obviously 0 is not a prime number actually, so the first prime number is actually a 2, so 2 is the only even prime number. Then the rest of them are going to be obviously odd numbers here, so it can only have 2 factors, 1 in itself. This is question number 17. X is an integer. Given that 27 minus 2x is less than 8, find the least possible value of x, so the smallest possible. So if I add 2x to both sides and bring the minus 8 over, I get 19 is less than 2x. Dividing it by 2, I get that 19 over 2 is less than x. So 19 over 2 as an improper fraction is going to equal to 9.5 or 9.5. Okay, so the least possible value for x would have to be 10, okay, because that's the smallest possible value that will satisfy that inequality region. Okay, so the least possible value, okay, so the smallest possible value of x. Remember that integer means whole number, okay, so integer equals whole number. Okay, this is question number 22. An inter-school swimming competition is to be held between schools A, B and C. Schools A send a team of G girls. School B send twice as many schools as A. So school B is going to be 2G. And school C send 25. There are a total of fewer than 85 girls. Okay, so write down the inequality on this information. Okay. So, if I was to solve this, I get G plus 2G plus 25 has to be less than 85, okay? So solving this, G plus G is 3G, 3G plus 25 is less than 85. Minusing 5 on both sides, I get that 3G is less than 60, so G is less than 20, okay, so G is less than 20. So I formed my inequality there. Part B, write down the largest possible value for G. Well, G could equal to 19, okay, so the largest possible team ever, so G could equal 19 girls, okay, so yeah, the number of girls could be 19. Number N-O for girls. So number of girls could be 19 for the largest possible value of G. Okay, so it should be 19 then for part B. Okay, right guys, that takes us to the end of today's video. So I appreciate it was quite like a long video actually, but I hope, yeah, it was informative and useful on inequalities. So when we solve inequalities this year, so it's treated like solving equations, it's just balancing both sides and keeping your symbols the same. Okay, I hope you found it useful, I hope you found it informative. If you did, please press like, please subscribe to the channel if you're new. Okay, and lastly, please turn on post notification by clicking that bell icon so you don't miss out on further videos and further uploads on my channel. Okay, but that's it for me today, guys. Thank you so much for watching. Okay, take care, stay safe, and I'll catch you in the next one. Okay, Merry Christmas and a Happy New Year.